Okay, this is the integration packet, and we are doing page 7, which is one of the extension pages. Page 7 through 9 talk about using trapezoidal rule, which is like an estimation method of finding the area under curve. Integration, of course, is better as long as you have the actual function, because you are going to find an exact number or a very close number if you use the calculator. Trapezoidal rule is basically taking a curve and making a straight line equivalent, so the estimation is worse. For some reason, they want to put that in the syllabus and they want to ask you questions about that on the exam, so here it is. Okay. The idea is pretty basic, so I'm just going to draw a little picture here so that you can see what it looks like. Basically, if you have the area under this curve, for example, we're going to divide it into a certain number of uniform width bars, like that. And then what we do is we basically draw points which show how high each of the edges of the bars are, and then we just draw a straight line in between them, and then we find the area of each one of these separate shapes, which each one is a trapezoid, right? And then that's why they call it the trapezoid rule. We're going to just find the area of these three trapezoids and add them together. You don't really need instruction to do that. You already know how to find the area of a trapezoid. But they give you a formula, this one here, which is in the formula booklet. And so with this formula, you don't really have to think about it that much. You can just plug the numbers in. What do these symbols mean here? Y subscript 0, Y subscript n, etc. So basically, Y subscript 0 is like the first height here, and Y subscript n would be the last height. In this particular case, it would be Y subscript 3, because we have 3 bars, right? And then the ones in between are Y subscript 1 and Y subscript 2, right? So basically what you would do is you would take Y subscript 1 and Y subscript 2, and you would put it in this group of heights here and multiply them you would multiply by 2, and then you would put the edge ones, Y0 and Y3, you would put them there, and you wouldn't multiply by 2, and you'd add all those two together. You would multiply the width and 1/2, which is basically just an extension of the trapezoid rule. And what is h? H is the width of one of these bars. So basically you take the entire width and divide it by 3, which is basically what this is saying. Okay? Now if you look at this formula, if it's more confusing to you than the process of cutting it up into 3 trapezoids and adding the areas together, then don't use this formula. Just cut it up into however many bars they tell you to cut it up into, and then calculate the area of each trapezoid and add them up. That is basically what you're doing. But if you understand the formula, you can use a formula if you want to. Okay, so that's all I'm going to say about page 7. And the beginning of page 8, they have a sample problem there, which you can look through if you want to. So what I'm going to do is I am going to do the first problem using basically the procedure that you would use if you didn't know the formula. I'm going to just find out the area of each trapezoid, and then I'm going to add them together. And then on number 3, I'm going to use the formula. Okay? All right. So here we have a function, a curve, and they give us some xy coordinate pairs. And the xy coordinate pairs are 1, 5, 3, 7, 5, 6, 7, 10, and 9, 4. And then they want us to estimate the area under the curve. We're going to cut it up into 4 trapezoids. Okay? So basically, the x values are 1, 3. I'm just drawing this graph so that you can get a better idea of what it looks like, but you don't have to draw this. And then so this one is 5 high, this one is 7 high, this one is 6 high, this one is 10 high, and this one is 4 high, right? And so basically the trapezoids look kind of like this, right? And we're just going to use our knowledge of finding areas of shapes to find the area of each of these 4 trapezoids, and we're just going to add them together to get the answer. We're not going to use the formula. Okay? So, by the way, what is the width of each one of these? Do you notice that they're all uniform width? They're all width 2, because 1 to 3, that's 2, 3 to 5, that's 2, etc. So the width is 2, right? When we calculate the area of a trapezoid, remember, the way we do it is we use the formula in the formula booklet, or we use common sense. We're basically going to take the average of the 2 heights. So there's like height 1 and height 2. And then there's like the base width, right? So we're going to say 1/2 times height 1 plus height 2. We're going to take the average of those two, and then we're going to multiply it times the base width. Okay? So in the case of this first trapezoid, we're going to average 5 and 7, and we can do that in our head. We don't even need to do 5 plus 7 divided by 2. The average of 5 and 7 is 6, right? So we're going to do 6 times the base width, which is 2. So the first trapezoid is area 12, right? The second one, we're going to just take the average of 7 and 6. The average of 7 and 6 is 6.5. And then we're going to multiply that times the base width, which is 2, and that will give us 13. And then this third trapezoid, we're just going to take the average between 6 and 10. That would be 8. We're going to multiply it times the width, which is 2, and so that'll be 16. And then the last trapezoid here, it's height 10 and 4. We're going to take the average of those two. The average of 10 and 4 would be 7. And if you can't do that in your head, you just do 10 plus 4 divided by 2. That would give you 14 plus 2, which is 7. And then we're going to multiply 7 times the base width of 2, which is going to give us 14. Okay? Now that we found the areas of 4 trapezoids, we just add the trapezoids together. The last 2 trapezoids, 16 plus 14, gives us 30. The first 2 trapezoids, 12 plus 13 give us 25. 30 plus 25 is 55. So the area under the curve is estimated to be 55 using the trapezoid rule. Okay? All right. Now let's do number 3. For number 3, we're going to use the formula. And remember, the formula is something like 1/2 times 1/2 times the width, and then we have all the heights added together, and the middle heights are multiplied by 2. Okay, so let me just write that down here. So 1/2 times the width. For some reason they call the width the height. And then we'll have like y0 plus yn plus 2 times the heights in the middle. Okay? All right, so let's take a look at this. We got 1, 2, 3, 4, 5 coordinate pairs. So that means we're going to divide it into 4 segments, right? Not 5 segments, because if you have 5 points, then you have 4 intervals in between them, right? So we're going to divide the entire interval into 4 segments, and the entire interval is -1 through 4. -1 through 4 is how wide? It's 5 wide, because you do 4 minus -1. That would give us 4 plus 1, which is 5. So our interval is 5 wide, but we're going to divide it into 4 segments. So each segment is going to be 5 divided by 4, which is equal to 1.25. I could do that on the calculator. Okay, so our h value is going to be 1.25. That's the width of one of the bars. And our y0 value is going to be 5, and our yn value, and actually in our case it's going to be y subscript 4, is 8. Okay, so I'm going to start filling in the formula here. So it's 1.25, and then I'm going to have 5 and 8, right? So 5 plus 8, the outside 2 widths, and then I'm going to multiply by 2 the inside widths, which inside heights, sorry, 7, 3.5, and 6. I have 3 of those, right? Okay, and I think I'm done. add these in my head. 7 plus 3.5 plus 6, that would be 13 plus 6, it would be 16.5. Multiply 16.5 times 2, that would give us 33, right? So I have 5 plus 8 is 13, so I have 13 plus 33 times 1.25 divided by 2. That would be 13 plus 33, that would be 46. 46 divided by 2. 46 divided by 2 is 23. So basically I have 1.25 times 23. And that would give me my answer. So let me do that on the calculator. 1.25 times 23. 28.75. Okay, I'm done. All right. I'll go to another video to finish up this packet.